So hopefully you feel like some of this you already know. That would make today a really nice day. We're starting with even and odd end behavior. So even degree end behavior, odd and odd behavior and behavior. Odd degree and behavior. When we did even and odd before, we were dealing with symmetry. So I'm just kind of separating it because there's 4 pieces that we care about. I've got positive even and positive odd. And then I've got negative even and negative odd. End behavior is just the ends of the graph where the arrows go. All the stuff in the middle doesn't matter. It's different than that. So all we care about is my end behavior. So positive even, positive refers to the end of the second half of the graph. It's ending high. Because it's even, it's going to go in the same direction. So it would have started high as well. So positive even looks like this. It looks like touchdown Jesus. For my Notre Dame or my football fans, right? Touchdown. Cool. Which means negative even should look like what? Yeah. Opposite of that. Odd is like opposite. Odd and opposite both start with O's. Because I've got odd positive, it will end high as well, but it's not going to still go the same direction. It's going to go opposite directions like this. So it's going to have started low, and it's going to end high. And that means opposite or odd negative would be the other way, where you start high and end low. I'm trying to go backwards for you guys, and it's kind of messing with my brain, like that. So we're graphing polynomials today. And 2 of the 3 things I care about is positive or negative, even or odd. Okay? Does this look familiar to you? Does this ring any bells? Okay, awesome. I think today will ring a lot of bells. Okay, number 1, it says examine on the calculator. We're not doing that. We're just going to graph by hand because I think you guys remember how to graph by hand. Let's start with even and odd, negative and positive. If I care about positive or negative, I care about that first term. So is this going to be positive or negative? Positive. When I care about even and odds, I care about how many x's I see. So I see 1, 2, 3 x's. There's no exponents to worry about. I see 3. Is 3 an even or an odd number? Odd. And then the last thing I care about is my x values. What are my x values here? I heard -3, -1, and I heard +2. What do we call those? What's a special name for those? Zeros? What's another name for those? Solutions? I can think of 2 more words for those. X-intercepts? And the last one, I don't know if we use as often, it's roots. Did you guys use roots ever? The roots? Maybe, maybe not. Okay, those are the 3 things I care about: positive, negative, even, odd, and what my zeros are. So we're going to go graph those. First thing I like to do is graph my zeros: -3, -1, 2. Then I personally like to put arrows out for my end behavior. I know it's positive, odd, so it's going to end high and it's going to have started low. Opposite ends high. And then once I have kind of my guideline, now I'm just going to connect my dots and I'm just going to cross at every 0. Cross, cross, cross. It's just a sketch. So if I were to graph it in the calculator, it might have higher or lower humps at different points. I don't care. As long as you cross through the zeros, have the zeros marked, have your end behavior, you are good. Is this ringing some bells? All right, let's keep it moving. Let's do a couple more examples and I'll let you try some on your own. All right, what about this one? Positive, negative? Negative. Good, even, odd? Ooh.
No, even.
I like odd. Why do I like odd?
Oh, wait,
the square means that there are 2 x's here plus 1 more is 3. Odd. Ooh, that square is gonna be something important to talk about in a second. What are my zeros?
-3, 2.
Yeah.
No zero.
Another
Something happens at that two. What happens at that two? Bounces. I bounce. Very good. So Meg, when you said another two, technically yes, that's like my zero. You can count it twice because I'm bouncing at it.
But why? Why is it?
I bounce because it's a square. If you raise a factor to an even number, you bounce at that one. Mhm. If it has no exponent, it's just a one, so we just cross over like normal. Okay, so let's go graph. I'm gonna graph -3 and 2. I'm gonna graph my negative odd. What does that look like? Show me with your arms what negative odd looks like. Starts high, ends down.
Yeah.
Does it look like this for you guys?
Okay.
All right, and then I just have to remember to bounce at 2. So I'm gonna cross at -3, and I'm gonna come up here and I'm gonna bounce at 2 if I can see my graph well enough. Oh, so then I come back down. That's good, right? Let's do another kind of funny example that we need to discuss. Jump on down to letter C. It says x minus 2 to the third. All right, positive or negative? Even or odd?
Even.
Odd because it's 3.
Odd because it's x to the third. And so we're working it out together. Odd because it's x to the third. So positive odd. And then what are my zeros?
-2.
-2 will go through. It's cubic, right? So that means that we need it to kind of like, I call it snake. I say that we kind of snake through because if I were to look at a normal x cubed, it looks something like this, right? It just doesn't cross right through. So I need you to get a little jazzy with it. Oh, why is it? It should be +2, shouldn't it be? That's on me. I'm so sorry. Thank you, Amelia. Great catch, because I was going to be really wrong in a second. +2, my bad. Okay, so now I'm going to go graph that. It's just at +2. Positive odd means that it looks like that, my little disco man. And then I'm going to just kind of try to snake through it, make it look a little cubic. Don't get too crazy, but don't just cross through either. That's not the same thing. And again, it's just a sketch. Nothing's perfect. All right, can we do one more together? Then I'll let you try a couple on your own. All right, let's do this next one together. Positive or negative? Even or odd?
Even.
Even. What are my zeros?
2 and
-2 and -4. Do any of them do anything funny?
Yeah.
Snake through which one?
4.
Good.
How do you do that?
Good. So let me graph my zeros, -4 and 2. And it's positive even. What does positive even look like? Good. Touchdown, Jesus.
Cubic.
So when I kind of snake through here, I kind of make it a little bit more dramatic and then I pop over like that. And again, when I grade, I'm looking, do they have their zeros clearly marked and they only pass through their zeros? Do they have positive and negative end behavior? And is there even or odd end behavior correct? I'm really just looking at 3 things. Okay, number 2, A and B are the exact same type. Do you think you can try those without me? Good, try A and B without me. Try A and B without me. You guys ready for me on A and B, or are you still working? Ready? All right, let's do it. All right, positive or negative on 2A? Good, even or odd? Even or odd? Even, good, I like even. What are my zeros?
Negative, negative.
Good, anything, anybody doing anything funny? Bounce at -1, good. Graph your zeros. Graph your end behavior, positive, even, we just did one like that. And then cross, bounce, cross. Yeah, something along those lines. Everybody okay with what I did? Okay. Let's do letter B, same idea. Positive or negative, even or odd? I disagree.
It's moving. Five.
I see 3 plus 2 is 5 plus 1 more. Yeah, there's an X out front. There's an X out front. And that X out front means that I have a 0 where? What does that X out front mean that I have a 0 at? 0, 0. Where's my other zeros at? 3 and -2. Do I have any bouncing or snaking?
Bounce on the -2 through on the 4.
Good, snaking through on the 3.
That makes sense.
And then I'm gonna graph those 0, 3, -2. Negative even means both are going down. So I'm gonna bounce on that -2. I'm gonna go through 0 and I'm gonna snake my way through that last one. Feeling good about this stuff so far? Good, okay, go ahead and flip your paper over. We're gonna do C and D and E, and we are gonna skip F and G for today. We will come back and do it later, so don't cross it out. We're gonna come back to them, just not today. Okay? What's the difference between C and then everything we just did? There's no parentheses. Parentheses is factored form. So this page all over here, this was in factored form. So it was ready to go. That was factored form. This is not factored form. This, I guess you could call it standard form if you want, but this is not factored out. So the very first thing we need to do on all of these is factor it. And then we do positive, negative, even, odd. What are my zeros? So before we do anything, first thing we have to do is factor. Then we can break it down from there. Okay. So when I look at this first one and I factor that first one out, do you remember how to factor when I have those 4 terms? Yep, good. We group them up together. These two go together, these two go together. Take a GCF out of each pair. Then we can bring the coefficients together, and then that x plus 3 just gets written once. Remember to go one more step. Can you factor out that x squared minus 4 one more step?
Yeah.
Good, that's a difference of squares. From here, we can tell our zeros really easily. What are my zeros? Good. Positive 2, -2, -3. Okay. Now you have 2 options right now. You can either use this new form to decide positive, negative, even, and odd, or you can go back to the beginning and look at just the first term. Okay. Either way, you'll see that the very first term, whether it's not factored or it's factored, is positive. So we're going to make that be positive. And then if you look at the factored form, I see 1, 2, 3 x's. So that makes it up, right? Now, if you want to look at the not factored form, you just look at that first term and you see how its exponent is 3. That's odd. You do not count x's when it's not factored, okay? So if it's not factored, you can't go and be like, oh, well, I see 3 plus 2 plus another one, I see 6. You can't count them unless there are parentheses. Is everyone okay with that? Okay, that is always a silly mistake that somebody makes, and I would like you to not make it. Okay, only count when there are parentheses. Okay, but either way, it's positive odds, so graph your zeros, graph your end behavior. None of them do anything funny, so we're just gonna cross, cross, cross. That's good enough. It kind of looks funky, but let it be. Do you think you can try the next one? There are 2 more. I'm gonna just work on them silently, but you try them on your own, okay? Factor them out, simplify them down, graph. I've got C and E up on the board whenever you're ready. Done, check in. If you're stuck, check in. If you're still moving and grooving, just keep moving and grooving. Check in when you're done. One of the reasons I moved the quiz to Friday or to Monday is because I wanted to do some graphing polynomials on there. Hopefully that should give you a bit of a sigh of relief to be like, oh, we're cruising on that. I'm doing good with that. Those are easy points for me. Also, the quiz on Friday will not be graphing calculator. So can we do any of those word problems we were doing yesterday? No, where we found maximum? No, because I'm not going to let you use a graphing calculator. So that won't be on there. We can talk more logistics on what will be or won't be on the quiz next class, but I just want to let you know graphing will for sure be. Okay. We got a couple other special types of problems. We're going to come back to F and G. The reason being is that you can't factor those easily. So we are going to have to use a different method that I'm not ready to talk about yet. So I don't want to bring that up because I don't really want to deal with it right now. Instead, we'll do number 3. It says write the equation of a cubic function with root 3, negative root 3, 6 as zeros. And then it says multiply out. If I know all of those are my zeros, can I write a factored form of that equation? What would one of my factors be? X what?
X minus square root.
X minus square root of 3. What would another factor be? X plus square root of 3. What would my last one be? x minus 6, good. Cool. Now, if it said don't multiply out, we'd be good here, but this one says multiply out, so let's factor, let's distribute, let's FOIL it out. Which two should you do together first? The square roots. Let's get rid of that square root by doing these guys together first, okay? So FOIL those two out. So I get x times x plus root 3 times x minus root 3 times x. And then what's root 3 times root 3? 3. Good, minus 3. Did I do any canceling in that first parentheses? Good, the root 3's cancel out. And so I'm just left with x squared minus 3, and then x minus 6. Just a hint, anytime we have a radical or an I, we're going to do imaginary numbers in the upcoming sections. If you have a root or an I, they have to go in pairs. You have to do the positive and the negative in order for them to cancel out like that. Yes?
Why is x squared negative x squared of 3 times positive x squared of 3 negative 3? Like the last one, how did you get that?
What's root 3 times root 3? Multiply inside. Root 3 times root 3 is root 9. And what's the square root of 9? 3. And I got a minus and I got a plus, so that makes it minus. Okay. Now I gotta FOIL out the next two. We're not done yet. As I FOIL this though, I'm gonna do it in descending order. So I'll do x squared times x. We'll do x squared times negative 6, and then negative 3 times x, and negative 3 times negative 6. So I get x to the third minus 6x squared minus 3x plus 8. So we can write equations, we can write expressions, and we can multiply out if need be. Go ahead and flip your paper over. We got another one like it, but this one says don't multiply out. Write an equation of the polynomial function with 3, negative 4, 1 with multiplicity 3 as zeros. Okay, pause. Have you guys heard the word multiplicity before? What does that do, or what is that? It can make it bounce, Amelia. The degree, it's my exponent. So that multiplicity of 3 goes with 1. So I will not just write parentheses, parentheses, parentheses. That last one will be raised to the third power. And I know which number goes with it because 1, it says 1 with multiplicity of 3. They go together. So that one will be what? What will be inside the parentheses to the third power? X minus 1, very good. And then what will the other two factors be? No particular order.
Minus 3.
Good, x minus 3, x plus 4. Notice this one says don't multiply out, so we're good to just leave it as is. Everyone okay with that? Isn't too bad. Okay. I got one more problem of this section, and I want to do 2 of the next one, and then the rest of the class will be yours, okay? Now, this next one is a little like non sequitur. It's a little bit out of like left field, but we've done stuff like this before. Use your calculator to write a regression equation of the quartic polynomial containing the points blah, 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 blah. Remember doing regression? We've done linear regression and we've done quadratic regression. Get those calculators out. Let's see if we can remember where regression came from. Remember what buttons we press for regression? I think that was section 1.1 maybe, so it's been a little while since we've done it. Anyone remember what button we pressed to get to regression? Not most. stat. Press stat, it's the one under delete. And in order to put the points in, we'll hit edit, but once we've done that, we'll come over to calc. And we've only pressed linear regression number 4, quad regression number 5. But they have others, they've got cubic and then they've got quartic. And they told us in the direction that they want quartic. So we'll press that number 7 once we get our pieces in, okay? So go back to edit and we'll press edit. And you need your L1 and L2 to be full of those numbers. Now, let's say you've got numbers in your L1, you can press clear, and you may need to press clear enter, but that should get rid of everything in your line. So I can go to L2 and press clear. Don't press delete. Every so often someone does that and I just make you restart your calculator. Because you'll want the L1, you'll want L2. Can't you do exactly that?
Yeah.
Yep, I got you. Okay, so go ahead. I want X's in L1 and I want Y's in L2. Okay, and I'll come put mine in a second. I knew someone was gonna do it. Okay, good. So we'll do, okay, second plus 2, I think is what Mrs. Hollis said. And so now you're cleared, and so now when we go over to stat, you have edit, now you have to go ready. So if you want to clear it out, you just press clear, and then enter, you don't press. Yeah. Put those straight X's in. Good question. We're gonna put our straight X's in, the L1, put our straight Y's in L2. That's weird numbers, don't you?
What's the dot? Plus
Okay.
C squared?
Plus C times X squared plus D
Do I need
times
to put like
X.
points, like only 75?
I was gonna put 0.75 or 1.2, but you can do it without, it's not that.
But like on the test, do like.
Yeah, I do 1/10. So let me get my L1s and L2s in and then I'll be with you. All right, once I put those in, we're gonna go second mode to quit out. And then we'll go back to stat, go to calc, and then I want you to pick quartic regression. And then you enter in until you get something that looks like this. You're getting really weird numbers, but that is okay. Yeah, Amelia. Let me see.
Like that.
Now press second mode to get out of there. And then press stat again. And then go over to calc. And then scroll down with support. And then press enter, enter. Until we get that's what I did. I think that'll be all right. I got really weird numbers. If you guys get really weird numbers, I am gonna write that equation down though. Y equals -2.2 x to the 4th plus 45.8 x to the 3rd minus 339.8 x squared plus 1075.3 x minus 1231. Last period, we were a little bit out of shape about this, and we were like, why are we doing this? Okay, first, the reason we're doing it in this section is the textbook had a question like this in this section. The actual reason why I'm teaching you regression is this is more like science and data. But if you get a bunch of data points, and I want to say, okay, if this follows the same pattern, how can I expect what we'll get if I pick a number outside my data set? So if I'm like, okay, this is what we got when we got these, but like, what would I get if I plugged in 12? What would my Y be? we wanna come up with this equation so that I could plug that number in and guess approximately what my answer would be if I plugged a different X in, okay? So this just models this behavior. Okay, it's a good data, thing, if you do any stats or any like, data analysis, you'll do this kind of stuff. Okay. Before I set you free to work on homework, I wanna do 2 problems in 2.4. 2 problems that I think are also review. Don't roll your eyes, Gus. Pound your brain back there, you rolled them so far. Okay, we are gonna do a long division problem. We're gonna do a synthetic division problem, okay? Yes, we're still worrying about these. Yes, they're still relevant, okay? Unless I tell you that you have to do one or the other, you can do whichever one makes you happy. But right now, we're gonna do one of each. Does that sound good? Okay, so let's see if we can remember long division and synthetic division. Okay, this is in 2.4. It is not on your quiz. It's not on your homework, but I want to get ahead a little bit. We're gonna write the second expression on the outside, and then we'll do our long division, and we'll write our first expression on the inside. Notice I have an x to the third, I have an x squared. I don't have an x, so I need to put 0x to fill that space. You gotta hold your placeholder. Placeholder. Just like when we multiplied or when we did long division of regular numbers, just like you did in Algebra 2, long division of polynomials, the number that goes here is going to be what number multiplies times x to get x to the third. What times x gives me x to the third? X squared. Good. So x squared goes here. Then I'm going to multiply that by x and by -1. X squared times x is x to the third. X squared times -1 is minus x squared. Now, before I draw my line, I need to change all my signs. Change all my signs.
You do that no matter what.
No matter what. Because I want to minus the x to the third, so I mimic that by changing all my signs, so I don't have to remember that I need to subtract. So then I cross that out and I get 5x squared. Do you remember what I do next?
Oh, put it up.
One more thing before I do the next step. Bring that 0 down, plus 0x. Then I ask myself, what times x gives me 5x squared? 5x. 5x. And then I'll multiply 5x times x and get 5x squared. And I'll do 5x times -1 and get minus 5x. And just like last time, before I do anything, I change my signs. I know I'm being a little dramatic, but I'm dramatic so that you remember to do it. Okay, then I combine, I get rid of that, and that becomes a 5x. And then what do? Bring that 2 down. And then my last step will be, okay, what times x gives me 5x? 5. 5 times x is 5x, and I'm running out of space. 5 times -1 is minus 5. Before I minus, I change all my signs. Said that weird, but next thing I do is I change all my signs. And then that cancels and I get 3. Remember what that 3 is? Kate? Exactly. So you beat me to it. I was gonna say, have you guys seen it like R3? And have you seen it as plus 3 over x minus 1? I want you to write it as 3 over x minus 1. Yes, Maddie.
So you won't change the second sign.
We have changed the second sign every time. So we minus, you just make the first one be minus, and then you change that one. And I use the word change so that no matter what it is, you just go from addition to negative or from minus to addition. So. Okay, we'll do another long division either tomorrow or Monday, but I just wanted to remind you. Synthetic is usually easier and usually our favorite. You guys remember doing synthetic division? You don't like synthetic division? Okay. Hot take, Joey. Mhm. A very short story that I could make a lot longer, but when I student taught, I was student teaching in Dayton, Ohio, and I was in some algebra 2 class. And the teacher started doing synthetic division, and I swear I never like learned synthetic division. Like we must just not have learned that when I was in high school, or it just wasn't part of the curriculum. But he starts doing it, and I'm like in the back, like taking notes, and I'm like, I have no idea what's happening. So one thing I don't like about synthetic division is it doesn't always make sense to me, like why you do what you do. To me, it's a pattern. Sometimes you guys as students like it because it's just easier, which I totally respect. I totally understand. But that being said, let me go over both of them so that you can make that decision later on. Okay, so synthetic division. Does anyone remember how we start or kind of what the word rule is here? Yeah, Avery,
Is there like a weird box,
there's a weird box.
like that number, or is it just the -2?
It's gonna be the opposite of this. It's gonna be x equals 2. So whatever x equals goes in that little box. Will go in that box.
Just to
All the numbers, all the coefficients, right? So we'll go 2, 4, -1, 1.
Isn't the last one like a fraction, something like that?
The last one will be my remainder, which we will write as a fraction. Then I give myself a little bit of space because I'm gonna write numbers there and then I'm gonna draw a line. First thing I do is I bring that 2 down here. And then I take that 2 and I multiply it by the number that's in the house times 2. So that becomes 4.
And that, maybe the 8 after that?
And then I add them, so it becomes 8. And then I again take the number under the line and multiply it by 2. So I get 16 and I add that to -1. So what do I get? 15. And then my number under the line, you multiply by 2. And that gives me 30. And then 30 plus 1 is 31. Now we got to use all the other numbers. I got to put x's and stuff behind them. It's going to be 2x what, Kate? Squared, very good. I'm going to go 1 less than what I started with. So I started with x to the third. I'm going to go down 1 and then I'll just carry it through. Oh. Brother Matt let me direct eye contact with me and close the door. I'm gonna have to apologize for that. I didn't say anything crazy, I guess I just. Or you guys, was it your year when Mrs. Wysocki closed both my doors? Was anyone in that class? Mrs. Wysocki was across the hall, she was in Father Jeff's room. And she, I think it was NWA testing, which is fair, but we were being so loud that she not only closed her door, but she came and closed both of my doors. And the first one we kind of were like, what is going on? And then she comes to the back and all of us were like jaws on the floor. It's crazy. But what's funny is I don't think I'm the loudest math teacher in this hallway. I definitely don't think it's me. But based on just those 2 incidences, it might be me, so anyway. All right, that was a small tangent, we gotta be done with it. Okay. Okay, you have the next class, I want those 2-3 homeworks, and we're gonna mostly review 2-1 to 2-3. I may do a tiny bit of 2-4, just depending on what I want to get done in the next couple days. But we're looking at a quiz on Monday for F period, Friday for